Okay, guys, let's get started with 71H science. All right, before we do this, we're gonna go over science notes.
Are you supposed to print those out?
No. What's that?
Say, oh.
All right. So for science, you have 40 questions and 35 minutes. After practicing, you guys should be able to finish this in 28 minutes with no problem. So there are three types of passages. There's a conflicting hypothesis one. This is the one that says like student one or hypothesis one. This is typically the longest section. There'll be 7 questions and you should take about 7 minutes to read this. And this one, you're always going to read the entire passage. Something you're going to notice on ACT Science, you don't need to read any of it, except for a few passages. Other than that, don't waste your time reading the passages. So to show you, this one, the conflicting hypothesis one, who can tell me which passage in this section we just did is that? Sid.
It's the gravity one, right?
Yes, it's passage 3. Good job. So this one is the longest one. It's conflicting hypothesis. So how you can tell is 3 people offered their input, and all 3 were different claims. And this one has 7 questions, so you should take 7 minutes to do this one. And you're always going to read this passage. The next one we have is data analysis. This one is you take 4 minutes to do this one. Some indicators for data analysis will say study 1 or experiment 1. There are typically 3 passages on the ACT for this. There'll be 6 questions, and you only need to read one of these passages. And how you tell which passage to read, it typically has a really hard diagram to understand. So who can tell me which one this would be? Which one would be, let's go through and say which one are all data analysis. Is passage 1 data analysis? No, it's not, because there's no student study 1 or experiment 1. Is passage 2 data analysis? No, it's not. There's nothing. What about passage 3? No. Passage 4? Yes, passage 4. It says right there, study 1. Passage 5? Yes, it says experiment 1. Passage 6? Yep, it says study 1. Passage 7? No, because it's just a diagram and then charts. Okay. Now, who can tell me which of those data analysis they would read? Varun, which one would you read? Which one has a hard diagram that you'd probably choose to read? Who wants to help him out? Go to passage 5. There's no way anyone would know what the hell is going on in that period. That is one weird looking diagram.
What, the line graph?
For passage 5. So what we typically look at is a diagram. If the diagram is complicated, a lot of people don't know what a current regulator is, a stopcock, a bead of H2O. That's all like complicated stuff. So you would typically want to read that passage. You'd want to skim it, underline the important stuff. Now, we have data representation. This is typically the easiest one you'll ever find on the ACT. This is 3 minutes. There'll be 3 passages, and there are only 5 questions. And again, you only need to read 1. So, who can tell me which 3 passages are data representation? Good. 1, 2, and 7 are all data representation. For number 1, is there anything complicated about this? This is just a couple bar graphs and pie charts. You guys should be able to read those. Number 2, this is a relative frequency chart. So you guys should be able to read those. Passage 7. Now this, if a lot of people are not used to electrons and protons because you start that in physics. So if you want to read it, you can, because this might be a little complicated. But again, this is only a suggestion that you should only read 1. You don't always need to have one, but typically there'll be one hard one. And for me, I would have read this passage because I would not really have understood this. Okay, now let's get started with how to answer the questions.
Wait, are you putting the score on the website for what we just took?
Yes. Everything you take in this class will always be graded. Okay, so how you do this. First thing you do, you see what type of passage this is. This passage 1 is data representation. Then you take a look at the graphs and charts. Are they easy to read? Yeah, these are pretty easy to read. I don't even need to read the intro. So I'm going to go right to the questions. Okay, I'm going to do one passage for you guys, and then you guys are going to do the rest, okay? So how you do it, you skim the question. Which of the 5 tree species had no surviving seedlings 1 year after emergence in the plot for which the herbaceous layer was undisturbed? So, what's the question? No surviving seedlings 1 year after herbaceous layer was undisturbed. That should be the only indicators that I need. So what I'm going to do, I'm looking for no surviving seedlings. So always read the axes. Seedling emergence, that's not the one I want. I want percent of seedling survival. And I'm looking for no survival. Which one has no survival? Well, it's right here. It's the one that's 0. So that one is yellow birch. Does that make sense to everyone how we did that?
Yeah.
So this one would be D. Alright, number 2. According to, whenever you see figures, studies, experiments, always underline them because that tells you where your answer is going to be found. According to figure 3, 1 year after emergence, the greatest, and always look for mathematical terms like that, greatest, least, 0, difference. The greatest percent of seedlings were from which of the following tree species in plot X and Y? So, go to figure 3. I'm looking for the greatest. So, what is that? That's 60% and that's 33%. Now I'm going to match that up with the key. Okay, what shade is this? Well, that's red maple. Same thing with the 30%. That's red maple as well. So, what's my answer? It's red maple, red maple. Good. It's going to be F. Number 3. So, typically, when you have long questions like this, it's the last sentence that tells you the question. But in this case, it's not really. According to the data in figure 3, so again, figure 3, so my answer needs to be found in figure 3 and nowhere else. What effect, if any, did removing the herbaceous layer have on the percent distribution among the 1-year-old seedlings in the 1 hectare acre forest? So the removal of herbaceous layer did what? Okay, so I'm going to go to figure 3. Now, whenever I can't find my answer here, I'm going to skim the intro. Right here, I don't know what plot X and what plot Y is. I need to define those two.
Wait, that's figure 1.
No, that's figure 3. It says right there.
Wait, are you talking about? Oh, that one.
Right there.
You're talking about the other one.
And can everyone see the mouse? Okay. So this is figure 3. Now, they said, what effect did removing the herbaceous layer have? I don't know what plot X and plot Y are, so I need to go and define them. Whenever you have an experiment, you always define whatever you're testing and what your variables are. So I'm going to skim the intro and I'm going to find what plot X and Y is. Plot Y is right there, and then where's plot X? Yeah, you don't even need to know what plot X is. You just need to know the herbaceous layer in plot Y was then killed. So the herbaceous layer was alive in X but killed in Y. And the question is asking what? What effect did any have on killing the herbaceous layer? So I'm looking at what effect did it have from going to X to Y. Well, look at all the percentages. Every single one is different. Nothing is the same from going to X to Y. So which answer choice does that align with? Which one?
C.
C. Good.
Wait, so we have for this question it was pretty easy because you just had to see the percent change. So you still had to go and read the intro, or?
Well, you kind of did because they want to know the effect of removing the herbaceous layer. How'd you know which one they removed it? What if they removed it in X but planted it in Y? In this case, you know all the percentages are changing. So if you never did that, that's okay. All right, question 4. Sid, tell me what I'm going to underline in this one.
Okay. So underline figure 1.
Good.
Then difference.
Difference in what though?
The seedling emergence.
Good. And that should really tell me. What else?
Greatest.
Good. Okay, difference. So I'm going to figure 1. I'm looking for the difference in seedlings emergence and where is it the greatest? Which one is it, Sid?
Well, let me check. Plot X and Y. It's yellow birch.
Good. Notice how this is going from almost 6 to about 0.5. That's this one right here is my biggest difference. All right, so the answer should be J. All right, Kritika, tell me what I'm going to underline in 5.
Figure 1. Just plot X and CG that will disperse.
Okay, so how am I going to do this one?
Go to the 1, and then the greatest number of like seedling emergence was 7, so I said always 7 or greater.
Good. So if 7 emerge, so 7 bloom, how many do we need to plant? We obviously need to plant 7 or more because you can't have 6 flowers bloom if you only planted 4 seeds. All right, this one is a brain question. You need to really think about this. It's all like logic. All right, let's go on to the next section. Who wants to do this one? Someone start with question 6. Tell me Brandon, what am I going to underline in question 6?
Figure 2.
Typically, on a lot of these questions, you're going to have a cause and effect, and they want to know what that does. So they're going to say, if one increases, what does the other do? Or as one decreases, what does the other do? So you got to underline both of those things.
So, will distance increase and then percent by mass of silt and places?
Good. So I'm going to go to figure 2, and I'm looking as distance increased, percent mass did what? So figure 2. Good. So as distance increased, so I'm going to the right. Always read your axes. So as distance is increasing this way, what is happening to my silt and clay, which is this dark one? So what is that doing? That's always decreasing. And that's going to be G. All right. Next one. Who wants to do it? Yes.
I underlined figure 3 and like the largest increase and cumulative percent by mass, and I got C for this one.
Good. Okay, so he underlined figure 3, largest increase. That's all we really need. So what are we going to do? We're going to see between which 2 data points was there the largest increase, and it's right here between 1 and 0.5. And like I said, always do your axes. Notice how this one's decreasing and it's not increasing. A lot of kids would have gotten messed up on this question, okay? So make sure you always read both axes and the scale they're using. And that is, in fact, C. All right, next one. Who wants to do it? Manvita.
Okay, so you underline figure 3 and diameter is greater than or equal to 0.5, and then what percent of total mass. So then you look at figure 3 and it says that 83% of the total mass is 0.25 or greater, so then if you look at 0.5 and above, it would be 62, because it can't be 83.
Good. Yeah, so what she did was you look at which class and matrix particles are greater than or equal to 0.5 in diameter. All right, so you go up to figure 2, and you're seeing what percent was 0.5 or greater. And you have to go to the left, not the right, because of the scale. So it's everything from 64 to 0.5, and you just line it up on the thing, and that's about, what is that? About 60%. And that is answer choice C. Or H. Alright, number 9, who wants to do it? So in these types of questions, there's a lot of reading, but the question is very simple. Okay, so who wants to do this one? Sean, give it a shot.
You would underline 270 kilometers.
But which graphs or charts am I even looking at before that?
1 and 2.
Good.
And then more than 50% mass. And what size class? and then you would get D.
Okay. So what are they asking for? They're saying figures 1 and 2 at site 270 kilometers. Which one is more than 50%? That's really all they're asking for. So figures 1 and 2, I'm going to 270, which is right here. Which one's more than 50%?
Andesite.
Good. It's this dotted one, andesite. Okay, next one. I'm gonna go to 270. I'm looking at which one at 270 right down here. Which one's more than 50%?
Sand.
Good. It's sand. So it's andesite and sand, which is D. All right, 10. Another indicator. Sid, you gotta stop talking, bro. I'm dead serious. Another one. Instead of looking for figures 1 and 2 or studies, when it says based on the description, that is an indicator for you need to read the intro. That is the only way you'll get your answer. So, who wants to do this one? Amitesh, give number 10 a shot.
Okay, you go look at the description in passage 2. At the end of the first paragraph, it says, the clasts are made of diameters greater than or equal to 16 millimeters, and the matrix has diameters less than or equal to 8 millimeters. So you go back to the question, and F would be right.
Good. So, you always, hey Kyle, take a seat right back there. You always look at the intro and you skim it. You skim it for the words you're looking for, okay? So they want to know, based on the description, how do class and matrix differ? Okay, give me 1 sec. Let me get Kyle started. Kyle, you can probably pull up. Okay. Alright, Kyle, just take a seat right here. And that's what we're going over, alright? No, that's not yours, that's his. So, right there, just take a seat right there, and we're working on science, alright? We're on question 11 right now. Alright. So, who wants to give Cal the SparkNote version of how we approach science? Lauren, tell him how to approach science.
So you first look at so you have to first see whether it's what kind of science question it is, and then that's based on whether you have to read it or not, whether you skip right to the question.
So how do we tell, what are our indicators for which section, which of these 3 types of passages it is?
If there's it's a conflicting hypothesis. You always have to read it.
Yeah, but what tells me it's a conflicting hypothesis?
If there's student 1, 2, and 3.
Good.
And then data analysis is when there's charts, right?
Well,
Easy charts? Or no?
that's data representation.
Oh.
Data representation is when there's easy charts and there's no study 1 or experiment 1. When it says study 1 or experiment 1, it means data analysis. Okay, so let's go on and get back to work. All right, so 11. I'm going to first go down and I'm going to find my indicator. It says student 1 right there. So when it says student 1, what does that mean? It's what?
Isn't it conflicting?
Yes, it is a conflicting hypothesis. Okay, so who wants to try number 11? Nithya, can you do number 11, please?
Yeah. So I looked at the student responses, and then student 3 said that they would both reach at the same time. So the only one that says student 3 reach at the same time is D.
Yes, good. So, notice how she made her life easy and only looked at one column and used the easiest one. Let's summarize what's going on in this. So they're basically sliding 2 blocks, block A and block B. Block A is 1 kg. Block B is 2 kgs. So I'm sliding one block that's lighter, one block that's heavier. And they want to know which one's going to reach the bottom first. So which line tells me the summary of student 1? Yes. Block A will reach the bottom first. Next one. What is student 2 saying block B will reach the bottom at first. And then student 3 says they're going to reach the bottom at the same time. So they're all conflicting hypotheses. Everyone says the other person's wrong. So for 11, suppose that a feather and a brick were dropped from the same height. What prediction would each student, what would each student predict? And there's comparing the feather to the brick to indicate the lighter block to the heavier block. All right, number 12. Which of the students agree that the acceleration due to gravity varies with the mass of the block? Manvita.
It's F because student 3 says that they would, like, mass doesn't matter. And the other two say that if it's heavier, then it goes faster. If it's lighter, it goes faster.
Good. So student 1 and 2 say if it's heavier and lighter, so the speed's going to be changed. Student 3 says the mass doesn't matter. They're going to reach the bottom at the same time. So yes, it is F. It's student 1 and 2. 13. According to student 2, as force of gravity increases, will the average speed what? Increase or decrease? Who can do this one? Manvita.
It's A because student 2 says that if the mass is greater, then it goes faster, so it would increase because the weight of the block is bigger.
Good. Yeah, these underlinings are not that good, but you guys can still read. So, what is the question asking again? It's saying, as force of gravity increases, what happens to average speed? So they're saying block B will be greater than the acceleration. That's not the right line you need to look at. Who can tell me where the right answer is for 13? Manvita, which line told you that that was the right answer?
Block B is heavier than block A, so the acceleration of block B will be greater.
Good. It's the one right above it. It's that line. Okay. 14. Who can tell me what to underline this? Amitesh. Actually, Krishay. How did I do 14?
So we would say based on student discussion,
Good.
and then have to underline acceleration of block A
Mm-hmm.
and acceleration of block B.
Good.
So now when you look at student 1, and when you look at the answer choices, there's only one answer choice which says that the acceleration of block A is greater than the acceleration of block B, so you choose that.
Perfect. And which answer choice is that?
G.
Perfect. Okay, so you say block A will reach the bottom first. So we know block A is accelerating faster, and as he said, there's only one answer choice that puts block A going faster, which is J. All right, 15. Lot of reading here, but what is the fundamental question they're asking? Venkat, give it a shot. 15.
Well, the questions, the last sentence with block X have the same acceleration. And I underlined block X, same acceleration, and block Y. I got D.
You got D?
Yeah.
That is not correct. Who can help him out? It is A. How'd you get A, Amitesh?
So we can eliminate B and C because if it's the same acceleration, the force has to be the same for the force. So we can eliminate B and C between A and D.
Okay. So right here, let's reread the question. Two new blocks, block X and block Y, have the same mass. Assume the relationship between Fx and Fy is the same as the relationship stated by student 1 between Fa and Fb. Consider also student 1's statement regarding the force of Earth's gravity on a block to the block's mass and its acceleration due to Earth's gravity. So what they're doing is they're basically switching block A with block X, block B with block Y. So let's see what student 1 even says about the force of gravity. They say the force of gravity on a block equals the block's mass times the block's acceleration due to Earth's gravity. So we're not changing the force of gravity or anything. They're just changing up block X and block Y. Because the relationship between Fx and Fy is the same, stated by him. So the force of gravity is the exact same. All we're doing is just changing up, and they have the same mass. We're just changing up the names of it. So it's going to have the exact same acceleration as what student 1 did in his experiment. Because we're not changing up anything. They're just trying to trick you by changing up the names of it. Alright, 16. The force of gravity on a block equals the block's mass times the block's acceleration due to Earth's gravity. Based on the information, that means we go look in the intro and student 3's assertion about the block's acceleration. Is the force on block A greater than or less than block B? And why? Who can do this one? Nithya, try this one.
I said less because I said J because blocks A is mass and blocks B is mass.
Good.
And I went off of the first sentence. So
You went off which one?
the force of gravity on a block equals the block's mass.
Okay, which equation is this basically?
Force equals mass.
Yes. So almost all of you guys should know F equals ma. That's Newton's equation. Alright, and that tells you that if the acceleration it's basically do you guys, when you guys took chem, do you guys remember your PV over T or your V over T equations?
PV equals RT.
Yeah, but there's another one where it's your VT or like regardless, you guys should know when you have F equals, let's see if I can write on this. When you have F equals MA in math, if you want to keep this the same and this is less, the only way to do that is to increase this one. Vice versa. So all just as one goes up, the other needs to go down. And using that philosophy, you can get J. Alright, 17. What do I underline? Let's see. Varun, give 17 a shot.
So you underline student 1 discussion and acceleration increases. Reach the bottom. Increase or decrease. I think it is C.
Yes, it is C. So how'd you get that? Okay, so student 1, basically, if you're increasing your acceleration, the time is definitely going to decrease. That eliminates A and B. Those two are out. Now we're left with explanations because the average speed will increase. Well, decrease, my bad. I said increase. So if your acceleration is increasing, your average speed will definitely increase. Does that make sense? That's just physics. Alright. 18. Kai, you need like a tissue or something? Alright. Next one, passage 4. 18, what do I underline? Nithya.
I said study 200 mg per day. And then I said figure 1, and then this was amino sugar and content. So I basically looked at figure 1, and then it said 200 mg per kg. So if you look at the y-axis, if you want, and then go down, it's closest to 175. So EG.
Good. When I go to 200 on my amino, draw my line over to the point, then go down to see what my amino sugar is, it's 200. It's really 175. This line is very poorly drawn. It should round down to 175. Does that make sense? All right. That's a very poorly drawn line, so that looks like 200. It's not. All right, 19. Consider the cornfield with soil that had an amino sugar N content of 350 in study 2. Based on figure 2 and other information provided, was the soil in the cornfield responsive or non-responsive? So what am I underlining? Rohit.
I underlined the 350 milligrams.
Good. But before that, what is this 350? Because on my axes, I can have 350 on this side or I can have 350 on that side.
Like the amino sugar N.
Good. So I'm underlining amino sugar N content and 350.
And then I underlined study 2.
Good.
And then I underlined figure 2, and then responsive or non-responsive.
Good. Another thing we also need to underline is other information. This tells us, what do you think that this tells us when it says other information? Brianna, where else do you think we need to look?
The intro.
Good. We also need to look at the intro. Why? Because we need to define what responsive and non-responsive means. I know it's kind of intuitive, but you need to always define every single variable in something, in a science experiment. So we need to see what responsive and what non-responsive means. All right, Rohit, so how'd you finish this one?
So like I went to 350 on the graph,
Good.
and then like it was at 0, so it was non-responsive because the yield didn't increase.
Good. All right. So, and where does it define non-responsive and responsive in the intro?
In the first paragraph, it says in a non-responsive soil, the yield does not change when the fertilizer N is added.
Good. Responsive. I'm in the wrong paragraph right there. Responsive soil, and then where's non-responsive again? Right here. Non-responsive. Those two places define the two variables we need. And then non-responsive clearly says the yield does not change. What is the y-axis on this? It says the percent yield, percent increase in yield. If that's 0, that means it did not increase. Hence, it is in fact C. All right, who wants to give 20 shot? Anita.
Under single one, it says thoroughly mix oven dried for 24 hours and then the amino sugar is analyzed and it says the same thing under 2, so the answer is J.
Yeah, this one. Wait, you said J?
Isn't it F? Oh wait.
Yes, it is
Sorry.
in fact F. It is not J, it is F. So the whole point of this is it's for measuring the mass, because they're basically just trying to standardize all the seedlings or whatever they're testing. I really don't remember this experiment, and they want to just dry it out so that they can weigh it on a scale. All right, and another question they typically like to ask is when you're straining something, and the question would be like, why are they drying it? Well, it's to strain it. All right. On the ACT, you're always going to have questions about how the process was when they ran the experiment. There's always going to be 1 or 2 questions. There are also going to be a few prior knowledge questions. Typically, they like to ask physics, like F equals ma, about photosynthesis, just very basic chemistry or physics concepts. All right, and there's really nothing we can study for those. That's just as long as you paid attention in school for the past 2 years, really, you'll be fine. All right, 21. What am I? I'm not good to go.
Study 2, greatest percent increase in yield, and amino sugar N, and increase in percent yield.
Good. So dumb down this question for me. What are they really asking?
So they're asking you what is the amino sugar the content in the cornfield, and what was its percent yield? What was the greatest one?
Good. So where am I going to go to answer this question?
To study 2.
And study 2.
Figure 2.
Yep, figure 2
And
mean.
then we're gonna look at the highest what the highest percent increase was, and that was 120, 22 actually, and then
Good, yeah, you just go to the one that has the highest. Yeah, you go to the one that has the highest percent increase. You see that's 122. Draw it down to the x-axis. You see that's 75 on the x. So it's 122 comma 75, which really should give you C. All right, 22. 22, the easiest way to do this, you look at what are they changing. What variable are they changing in the 22? In this entire experiment, Lauren, what variable are they changing out of these 3 things?
3.
Yes. The only thing, and how do you find that? Well, do you guys remember mix and dry?
Yeah.
Okay. What that tells you, when you have mix, you're, what is it, Varun? Or not Varun, Sid.
Manipulated variable independent, and then that's the x-axis.
Good. So what this tells us, this is what we're manipulating, and this is the response to that. This is a dependent respondent y variable. So, whenever I want to see what I'm changing, just go right to the x-axis. What am I changing right here?
Amino sugar.
Good. And then what am I changing in the other figure as well?
Amino sugar.
Good. So that means the only thing I'm changing in this experiment is 3. Everything else must stay the same. When you have 2 variables that are affecting an experiment, that is no longer a valid experiment. That's what we call confounding variables. Okay, you can never have that. You always need to create a cause and effect relationship with an experiment. So that tells us that, what is the right answer for this one?
2.
Yes. Wait, what?
G.
Yes, G. Yeah, not 2. Don't say 2.
But aren't they asking you how you would keep it identical?
What they're asking for is, if I have plot X and plot Y, how did I make sure that I standardized my experiment? They need to have the same rainfall and sunlight, because both experiments are manipulating amino sugar end content. If both of them are manipulating amino sugar end content, everything else must stay the same.
Oh, yeah, never mind.
Does that make sense to everyone? Okay. 23. Who can do this one? And whenever you never need a calculator from any of these math questions. Kritika.
So you go to study 2, and then it says that
Well, first of all, what am I underlining?
2.5 hectares, study 2, kg and fertilizer, and then you go to study 2, and you see that the fertilizer N was added at a rate of 122 kgs, and they're asking, this is I thought it was.
Okay,
Okay.
Mamnita.
Okay, so it says that it's N per hectare, so if there's 2.5, then 120 kg N per hectare, so you would multiply 120 by 2.5 and get 300.
Good. So what she's basically doing is, we're going to look at our rate right here. Where did that go? Right here. What this thing is 120 kgs per 1 acre. So I'm going to write 1 acre gives me, good, 120.
So 2.5 gives you that
2.5 times.
Good, 2.5.
proportions.
2.5 gives me x. Perfect. And then cross multiply x times 1a, x times 1 acre, which is 1. 1x is equal to 2.5 times 120. Always do dirty math. You know this needs to be above 240 because 12 times 2, so it has to be 300. You don't need a calculator for this. Alright. Next one. So, this one, it looks complicated. Okay? There's a lot. The diagrams are not complicated, but the charts are not complicated, but the diagram is. So typically, you just skim this real quickly. Okay, you don't read in depth, you skim and you underline important stuff in here. In reality, you really don't need to read it if you don't want to. So let's not read it. 24. Based on the description of step 1, what was the total voltage? Total voltage that was produced by the stack of batteries in the trial of the experiments. So I'm going to go to step 1. What?
4.2.
Good. How'd you get 4.2?
Because 1 is 1.4, so 1.4 times 3 is 4.2.
Perfect. And where does it say how to do that?
Step 1.
Okay, so it says, in parentheses, so that their voltages were added together. 1.3, 1.5 batteries were stacked, so their voltages were added together. 1.4 times 3 is obviously 4.2. Alright, 25. Hey Cal, bring down a couple of tissues if you need, okay? 25. If trial 4 had been extended, at approximately what time would 0.45 milliliters of O2 have reacted? I want you guys to annotate the rest of this passage and just write down, underline what's important, and find it in the graph. So how you should do that is, let me show you. This is how science homework should be annotated as well. You're going to find it where it's at, wherever it's in the chart. You're going to find it, circle it, and write that question right there. So question 9, the answer is right here. Like that, I want you guys to find me where my answers are. If the answer was found in the intro, underline which line that is and just point out to the question, write down the question. Okay? Do that for this passage, work with the people around you, and finish this one passage, okay? And then we're going to go over it in a minute.
Oh, I was actually you know. I know. I thought this was like I probably should okay, so but like if you try one is and then you realize like and then like if you like experiment oh wait, no, it's this one that I don't. What do you do? So I'm not a right now. I'm gonna be there. And this one is okay, but you know, because it says that it 10 and 8 to get you to leave. Okay, let's just go hard. I'm going to be 10 has experience to 0.
Yeah, this one is
okay, why it says in trial 3 right here. It's taking too long. It says in trial 3, if tested that means 0 SLB because they use the same. And then right here it says trial 2 is repeated in trial 3. And then trial 4 is first.
Never mind, I'm going to
AB is SLB. So it's 26 is right here. 26 is in trial 3. Have you got like 5?
I've never been to
I already got it.
I think probably.
if you look at
Oh yeah.
Actually, my mom did that.
I was tired.
longer to get to
You put more time than the round one day.
It's pretty bad. Well, like hundreds of
You did all one.
final volume.
Oh, you did?
Why did they tell me to reference it?
That's it.
You wrote it or not? You put one in.
Yeah. Number you want
Well, now I'm 10. I really am. It's like grade higher. So you still get your senior year. I still get the prize. You kind of suck at okay, so underline it's like a 9 and if the number and the number of VABs increase, and then I social
No, I didn't.
I'll do it.
I did acid.
No,
Where we find
I'm small, but I'm at
Oh, answers B.
Oh, I'll say trial 3 is steeper than trial 1 and only has more. And it has
No, because it's
more
I didn't get to
CAPs.
the draft rate, remember?
It says it right here.
Yeah.
This is how easy it is.
Most only more on.
I'm just like this.
I'm just gonna circle all of these. What is it?
And then
And then I'm
oh,
going
in
to
the day, yeah, like,
2 times 5.
All right, you guys ready?
Is it less than
25. Let's get started.
Yeah, that's what
Sean,
If you go to
give me 1 sec, Sean. What, Mama, go what?
So like for this one, doing equations do this way. Multiply what's in front of the O2 and what's in front of the n.
If I'm doing this one.
Okay, wait, let me
Yeah.
try these.
Isn't that the balance of the equation? You have to-
Yeah. All you do when you're on a balancing equation is interact.
I don't know, they're asking. No, she's asking. She's asking for. I asked two of the games.
Oh,
So,
you got it.
no, I think. So I use chemistry
That's
for.
why
Yeah.
You'll see.
So, yeah, you're just gonna look at this one.
Wait, how do you do Okay, so she got it. Okay, how do you do 29? So it says 10 MA and it says 20 MA. So I just
Wait, what do you
put it in half. And so it's 40, and so then I got 20.
No,
So that's it. My post
I get on all fours and check for it. It's not here.
Trial 1 had
Just take a time.
Yep. But even here, it's 4. It's not here. It's not. It's not trial by trial. Because this one is. This one is trial 1 by 4. And it's asking to say F10 on millimeters. Right here, it's 1 millimeters. So if you take, it's 20 divided by 2, so you take this 0.4 divided by 8. So you do 0.2. So you do 0.4 divided by, just divide it in half. Just divide in millimeters. That's 0.2. Oh, wait.
Do you see LeBron? You look like
Well, no, I got
Wait, 0.25?
No, but it's less than 4.
Okay.
You look like a rap from Sausage
Come on, when you read.
I know, I
You look like
Alright, guys, let's get started. Sean, 25.
you would underline trial 4,
Good,
and then 0.45 of O2.
good. And then,
And
yeah,
then,
O2. Good.
And then you go to trial 4 on experiment 2 in figure 2,
Yep,
and then you just extend the line, and you'll see that it goes to 240.
perfect. And scroll right down to the x-axis, and it's 240 right down there. Alright, so that is C. Alright, next one. And 24 was G. Oh wait, 26, critical.
So it says how many SLBs were tested in experiment 2, and it says under experiment 2, it says that there were.
doesn't say number SLC.
Oh yeah, it's under experiment 3. It says experiment 1. It says
Alright, calm down.
in trial 3, 3 ZABs were tested, and it says it's either ZAB or SLB at the beginning. So if there were 3 SLBs, ZLBs, they're only 0. They're 0.
Good. So they're asking how many SLBs were tested in experiment 2. Even if you go to experiment 2, you can see trial 3 was repeated. So that means the protocols they used were in experiment 1. So I'm going to go here, and I see in trial 3 they did 3 ZABs, which means there's 0 SLBs. Whoops. Okay. And that is F, 0. Alright, 27. A chemist predicted that the volume of O2. Who wants to do this? Lauren, give 27 a shot.
So underline volume O2, underline increase. I don't know, I feel like I got the one. Faster rate, and then 3 batteries was increased, and then trials 1 and 3.
Okay.
Okay, and then we looked at figure 1, and that because it has trial 1 and 3, and then we looked at like the highest point on both of those, and then in trial 3, it was we chose A because in trial 3 it was reached sooner than trial 1.
Good. So they're basically saying a chemist predicted that the volume of O2 reacted would increase at a faster rate if the number of ZABs present in the stack of 3 bags was increased. So what we're going to be looking at is from trial 1 there's 1 ZAB, but in trial 3 there are 3. So we're going to compare those two. So we can compare trial 1 and 3. Notice how trial 3 has a steeper slope. That means its rate is faster. It's reaching 0.4 at quicker than trial 1. Hence, it is yes, and the reasoning is in A, which is because the final volume was reached sooner in trial 3 than it was in trial 1. And another thing that you guys should know, for rates, whenever you have a faster rate, that means you have a steeper slope. So your line is more vertical. 28. Rohit, give 28 a shot.
Okay. So I underlined 5 O2 molecules are consumed. Then like ZN atoms, and then must also be consumed.
Good.
Wait, so what is it?
What's that?
Is it 10 or 5?
Well, let Rohit answer the question. Rohit, let's finish off.
I don't really get this
Okay, so for Sid, help him out.
I don't know. I'm probably wrong. I feel like it was 5.
Okay,
Because
so what they're saying is whenever you have an equation, a chemical equation,
that O2 is 5.
what, Brianna, explain it.
Oh, okay. So you're just balancing the equation. So since it's 2 Zn to every 1 O2, so if you have 5 O2, you would have that times 2, so it's 10 Zn.
Good. So this is basically cross multiplication if you want it to be. I think that's easier for you guys to understand. So if I have 2, that should be a 2. Okay, let me start again. If I have a 2, Zn equals 1 O2. Now, in the question they're saying I have 5 O2 actually. So if I have 5 O2, good. And then I just put this as x, and I'm going to solve this cross multiplication. 5 times 2 is 10. That means 102 would be 10 Zn. Make sense? Alright. 29. Kritika. Actually, Mandita.
Okay, under experiment 1 it says it's the current of 20 milliamps and
First of all, what am I underlining?
okay, trial 1, 10 MA, 200 seconds, and volume of O2. So then under experiment 1 it says 20 milliamps and in the question it says 10. So you would divide. I forgot how to do this.
Okay, so
Kritika, help her out.
so it says 20 milliamps in trial 1, and then trial 1 says, it says 10 milliamps in trial 1, and in experiment 1 it says 20 milliamps, you just divide it by 2, and then you get what it is for 10. So you look at trial 1 on figure 1, and at like 325, it's like 4.
Alright, hold up. Brianna, you go sit there. Sid, sit right here. Sid, get up, sit here. Nitya, go sit where Varun's sitting. Sid, I'm not putting up with your shit this class, bro. All 3 of you guys now. It's not Varun and Shalom. Let's go, come on, guys. Brianna, I only chose you to be the tallest person, but if, you can still see, go. Alright? By the way, guys, your parents aren't paying me for you so you guys can talk in this class, okay? They're paying so you guys can get a 34 and above. Okay, sorry, Kritika, I interrupted you. All right, start over from the very beginning for this question.
Okay, it says in trial 1, it is repeated except the current is 10 milliamps. In trial 1, it was actually 20 milliamps. So if you go to like the trial 1 graph, at like 325 or so seconds, it says it was 40 milliliters of oxygen. 0.4 milliliters of oxygen. And so since it's 20 and 10, you just divide it by 2, and then you get 0.2 milliliters of oxygen. And so I said it was less than 0.25.
Good. What's that? Give me 1 sec. My laptop's about to die, and I'm at 1%. Explain it to anyone who needs to.
Yeah, it's just a graph.
He's calling 911. Dude, what the fuck is that, man? Red cat. Okay, I'm just gonna blame it on the and I was not from
And he's still on
All right. Did everyone understand this question? All right. Let's go on. Passage 5. All right. Who wants to start with 30? Yes. All right. Rohit.
So like, you have to underline study 1. June 2007. And then table 1. And so I got G.
You got G, and that is correct. So how'd you get that?
It just said like in this table, genotype like lowercase both of them like E, and then it said phenotype below, and then 0 to 9 plates and like head only. So that's like where I got it from.
Good. So they're basically asking in study 1, June 2007 had 7 plates. That's the indicator for this one. It's the 7 plates. According to table 1, this fish had which phenotype and which genotype. So I'm going to go over to table 1, and I'm going to look at numbers. Which one had 7 plates? Well, it's 0 to 9, so it needs to be a phenotype of low and a genotype of EE. What is genotype versus phenotype? Mandita.
Genotype is like the letters and phenotype's like what's like the physical appearance.
Good. So genotype is a genetic makeup of the organism, and then phenotype is the physical characteristics. And that's an important thing to know. All right, so, and that is in fact G. All right, 31, who wants to do it? $31. Krishay, give 31 a shot.
So I was going study 1 too. Then when you look at that table and in the graph, you can see that the bottom says juvenile, adult, and breeding. So you know that there were juveniles collected in study 1, and there were adults that were breeding and not breeding too.
Good.
So we choose D.
Perfect. So what he did was 31, he went to study 1. He just read right at the axes. You have juvenile, you have adult, and then you have a little section of adults who are breeding. So that is all 3 of them, which is D. All right, 32, who wants to do that? Yes, Sean.
So you highlight study 2, and then 62 millimeters in length, and then EE or EE, and then you just look at the table next to it, and you see that like the bottom of the 2 lowercase e's are longer, and there are more of them in the 60 to 64.
Yes. So one of the offsprings measured in study 2 was 62 millimeters in length. Based on the results of the study, was the genotype of this fish more likely EE or lowercase ee? So you're going to go to, well, you know it's 62. You're going to see which one is 62, and it is most likely this one. And you just read over to the phenotype, which is lowercase ee. Make sense? All right. And then 33. Or I forgot to give you guys the answer. The answer is J. 33. Who can do this one? Who can do 33? Manvita.
I did B because first underline study 2 and then which of the three genotypes. So I did greatest number. So I did B because the most of the fish were like in uppercase E, lowercase e.
You said uppercase E, lowercase e. Well, they want the ones that are. One sec. It is lowercase e. How'd you get that?
Because there's more dark on the graph.
Good. Another thing you need to do, this is what I was looking for. So they're looking for it's not just, what you need to underline as well is study 2 and then the sexually mature offspring. Because that's what defines these fish. So, and it's also in May of 2007. So what you need to do is you're only looking for SM, because what is SM? That is sexually mature. So you only care about the dark ones. So this one, look at the y-axis on this. These are all higher than the previous one. So it is lowercase e. Always refer back to, always define your variables. Does that make sense? You don't want to look at the light shaded stuff. You want to look at the dark shaded stuff because those are the SMs. All right, 34. Who wants to do that? Brianna, give 34 a shot.
So you would underline do the results of study 1 support this prediction? That's the actual question for it. Well then it really talks about the movement of the freshwater environment.
Okay, so what exactly we're doing? We're moving a marine stickleback to fresh water, and will this result in the increase of the fraction of offspring with low phenotype? So go on.
So then we would go back and reference study 1, and then I chose J.
J is not correct. Can anyone help her out on this one? Sid, why don't you help her out? 34.
Okay.
Nithya, why don't you help him out?
I said F because according to study 1, according to figure 1, the increase of the population, the increase in the graph was 0.13.
Good.
From the beginning to the end.
Yes, that's all you really need to look at, and that'll give you F. All right, 35. Who can do that? Again, this one's measuring your protocol, so testing if you can run a standardized experiment. And also it's kind of like logic based. So who can do this one? What is this experiment? They're basically fish mating in the same pond, right? So how do you differentiate between who are the kids and who are the parents? Tagging you. Yes, so that's why it is B. All right. Take another couple minutes, work with the people around you, figure out the last passage, and then we're going to go over it. We'll finish around 11. 11. We have another thing to do. English. We got stuff to do, Cal. This is the only way you get a 36. Hey guys, for anyone who gets a 36 in this class, we'll pay you $500. I will give you $500 in cash. On your real exam, if you get a 36, I'll give you $500.
How many tries do you get?
Oh, yeah, tries? No, you get one try.
Or no, you definitely didn't take one.
On that, yeah, I didn't.
How many times you take it?
I took it 3. Jason took it twice. Yeah, because you typically in classes, like, I made you guys take it, but none of you chose to take it. It doesn't hurt to take it in the beginning of a class. When I took my class, I was a week into my class, and my teacher made me take the test. And I did. Got a bad grade, but that's fine. I knew where I was at. Which is very important to know where you score. Because, well, that's the only way you know how smart you are at that point. So, right now we can't do it, but, well, yeah, you could have taken the June. Did anyone take the June test? Okay. So, yeah, right now in the summer we can't really do that. The first test we have is September, so that's the one you're going to take. Okay? Even if you're not... What?
When's the one after?
September, October. So even if you're not ready for it, take the September 9th ACT. But I am dead serious. Whoever gets that 36, I'll pay you. Okay, that's your motivation right there. And the other motivation is you'll get into whatever school you want to. Alright, finish working on the last passage. Yeah. What? 7? Oh, shoot.
For the first one, I got G because you have to underline something like trial one, and then
Yeah.
trials 13.
Sean, what's up?
He doesn't have a question.
Okay.
Okay. So K is like these ones, so like PE, like these ones are increasing. These ones are increasing. This one is decreasing. No, like okay, so like the numbers they're like going up, right? And like they're the same order in here. These are going down. Yeah. Okay. I didn't do that.
Y was greater than 1,002.
Yeah.
Arnold, what are we doing for the rest of the class?
English.
So what, like the test that we did?
No, another test we have. You gotta go soon, right? Okay.
So can I do the test?
Pick up an English test, do it at home, and send me a picture of your Scantron. Okay, then watch this video, and we'll go over the annotations.
Which video?
The video that I'm taking right now. Give that 10, please. Yes. What? Cal, unless you're sick or dying, you can't go home, buddy.
I feel like I'm dying.
Cal, I literally stepped at 3 a.m. Like, you're fine, okay? What? For Water Wars, but like
Oh,
still.
yeah.
You guys won?
Yeah, we won, but still.
How much more you get? A grand?
We get 60% at 3,500. I don't know what that is.
Who was on your team?
Okay, that's not important. Let's finish. We can talk about that after.
But you didn't get shot though.
I got shot, but we.
No, but like not by
What? Oh, no, yeah, not by that.
You get 60% of 3,500.
What?
You get 60%.
No, we split that amongst the 5 members of the team. Alright, Kyle, you're fine, bro. Just work, okay? Alright, you guys almost done?
I don't get this one.
Which one?
Like the whole thing.
Okay, well, I'll go over it. Okay, guys, let's go over this now. Come on. 36. Who can do this? Manito.
Okay, so you underline table 1, trial 1, and trials 13 to 11 through 13, and then K increase. So you look at the little table, and like for the 4 medium things, the K is increasing. So when you look at trials 1, 11, 12, and 13, the mediums are increasing, and the FX is decreasing. So it's G decreasing only.
Good. So basically, you just look at this little column right here, and they're saying as K is increasing, so as I go from air to NP, what happens? So I'm going from air all the way to NP. What's happening from trials 10 to 13? What's happening? My FX is only decreasing. Hence, it is B or G. Next one. Suppose, who wants to do this? Lauren, 37. Give it a shot.
I was like,
Okay. So what's going on in this experiment? Who can explain? Who can explain what's very simply what's going on? Alright, guys, basically it's 2 charges, or 2 spheres that are being fastened to the floor. There's a medium that's being filled in the space, okay? Then you're measuring when you have 2 electrons, when you push them together, they're going to repel, okay? Same thing with 2 protons. They're basically measuring how far are they pushing each other. And they're measuring with different mediums. That's all this is. And what they're saying in this question is, suppose that sphere X had become unfastened. Okay, so it's no longer being strapped to the bottom of the box from the floor of the vessel during trials 1 and 7. So underline that, trials 1 and 7. During which of the trials would sphere X more likely have undergone lesser amount of acceleration? So, when I have a charge and it is, I forgot the unit they use for charge. When it is, they use columns, that's it. So when I have a charge that is -1 columns and -1 columns, they're going to push each other. But if I have one that's -1 and -4, it's going to go at a faster, it's going to accelerate faster. Hey, Venkat, why are you turned around? Okay, but like right now I'm going over. Do you have eyes in the back of your head? Alright, so why don't you turn the chair around, buddy? Alright, that's good. Alright, so does that make sense? 2 protons, when they're the same charge, they push each other away. Alright? But when when one has a bigger magnitude, it's going to accelerate at a faster rate from each other. So what they're saying in trials 1 and 7, let's look at them. So how do we differentiate between trials 1 and 7? We go trial 1, 7. What's different about these two? Well, it's the charge of the other. It's the charge of the other sphere. One has +1, +1. The other one's +1 and +4. Which one do you think is going to repel faster? Which one, trial 1 or trial 7? Trial 7, yes. Because this one has a stronger charge, so it's going to want to get away from the other quicker. Okay? Do you guys remember the saying, opposites attract? Okay, that's what you need to remember. This is a bit of prior knowledge, because you need to understand the idea that like charges repel. Okay? So, if those two repel, which one do you think is going to have a lesser acceleration? Remember, this one had a 1-to-1 charge. This one had 1-to-4. So which one, Varun, which one do you think is going to have the lesser acceleration?
Trial 1.
Good. Trial 1 because it has less charge on both spheres. So that gets rid of C and D. Now how do we differentiate between A and B? So C and D are out. Now let's differentiate between A and B. So because the magnitude of the electrical sphere by sphere y on x was greater, was the magnitude of the repelling greater on trial 1 or 7? 7, because no, 7 wanted to get away quicker.
Oh.
So it obviously is not A because the magnitude is not greater in sphere 1 than in trial 1 than 7. All right, hence it is B. All right, 38. Who wants to do it? Yes, Sean.
You would underline each, and then because it's like all 13 trials, and then
Bless you.
sphere x on sphere y, and then sphere y on sphere x, and then you just look at like the f's on the table, and the answer would be H.
Good. Another way to do it is when you have two protons or electrons, they exert the same force on each other. Okay? That's just a law in physics. I don't really remember which one, but it's just a rule. And as well, if you don't remember that, you can check the force of sphere on force of y. Fs and Fy, notice how they're all the same. All right, 39, who wants to do that? Who wants to do 39? Venkat, give 39 a shot.
Okay.
Says C,
How did you get C?
because they only talk about electrons.
Nope, not C. How'd you get A?
It says -1 +1. So that means QX has to be electron, QY has to be proton, because the electron has
Good. That's basically it. Knowing the charge of an electron is minus and the proton is positive. All right, 40. Who wants to do it? Nithya, can you try 40?
Mm-hmm. So in trial 9, they were both positive. So they have to be the same. They have to be going in the same direction. No, they're both positive, so they have to be going in opposite directions. So they have to be pushing away from each other. So sphere Y will be going west, and sphere X will be going east. So it'd be G.
Good. Again, the whole passage was based off the idea. Do you know when you have two positives, they repel in opposite directions? When you have two of them, they shoot out away from each other. That's when you put two magnets together, they shoot apart. All right. How'd you guys think this was without reading the passage? Were you guys able to do it? You were able to do it, Sid. Everyone was able to do it? Okay.
Two of the sections. Like the first two.
Yeah, the first two are easy, but that's why you can you can do those a little quicker and you can spend some more time on this. But regardless, you should finish in 28 minutes.
Wait, on the CT when we go, we get like you can see the time.
You cannot see the timer. It's like an old-fashioned clock. Some rooms don't. What? Yes. I should have reminded you guys a while ago. Everyone needs to get a stopwatch for Sunday. Okay? If you don't have a stopwatch, we have a timer that goes here like normal, but soon I'm not going to show that anymore. You guys need to get a stopwatch, okay? As well, bring a graphing calculator on Sunday. Don't forget a graphing calculator, okay? What? Tomorrow Sunday? Yes, tomorrow Sunday, yes.
Wait, are we doing like the whole test?
We're doing a full test tomorrow. So bring a snack as well. It gets pretty cold down here. Wear layers if you want. Okay?
Wait, like everything?
Everything. It's a full ACT test tomorrow. Except for writing. Okay? Alright. You guys are going to take another 40... Let's see. Which time we have? Okay, so you guys are gonna take 36 minutes. We're gonna do the first 3 sections of the next English section, which is 71E. Okay. So I'm gonna give this to you guys in a minute.